Good morning, everyone. Today we'll take an example to see how an error syndrome helps in correcting an error occurred in a block code. So let's take a numerical example. Since we have mentioned that it's a block code, we also need to mention its size. So we are assuming here that we have a 7-4 block code and it has to have a generator matrix. We will also assume that we are having a generator matrix for this 7-4 block codes. Let me write down this generator matrix for you, and it has two parts. One is the identity matrix and one is the parity check matrix. So let me partition this thing into two. So one part is the parity check matrix and one is the identity matrix, and we will form a hypothetical generator matrix for this 7-4 code, where this identity matrix or the first part of the matrix is going to be the same for all generator matrices. 0 0 0 1, this part needs to be same. This part can be different, that makes the generator matrix different from one another. 1 1 1. We have this generator matrix for the 7-4 block code. Now the parity check matrix is given by H, which is a modification of this parity matrix P. Transpose of P is PT, and we append it with this identity matrix of size n minus k, where n is 7 and k is 4. So we have a this much size parity check matrix. So we have this P here. We will take its transpose and form this first part of this matrix. So let me partition it into two parts. One part is P transpose and another part is this I with size 3. Now how to transpose it? Just replace rows by columns, and so we will have the first row as 1 0 1 1, second row as 1 1 0 1 1 1 0 1, and third row as 0 triple 1. And let's write down this identity matrix of size 3 here. 0 1. This whole matrix is the parity check matrix H. Now for a message block of this size, let's assume that this message block is D 1 1 0 1. We have taken a 4-bit message block because the size of this was 7 4. The code vector corresponding to it, C, is equal to D into G. So let's multiply it, this with this. Let's multiply them together, which will give you C is equal to, let's do it carefully, otherwise there is a chance that we will do some mistake. It's going to be a 7-element vector, okay, because this whole thing will be multiplied with these values, and we will have a 7-element vector. It's going to be 1 1 0 1 to this partition, and 0 1 and 0. So we have the C here. Now in the last lecture we had calculated the syndrome and also discussed about its effectiveness in correcting a code. So we have the syndrome S that was given by C into transpose of this parity check matrix. C we have calculated here. We need to multiply this with the parity check matrix. Parity check matrix is this one. So we are going to multiply this with the parity check matrix. So there are two multiplications involved up to this point with the parity check matrix. One is multiplying D with G, another D with the generator matrix, and we need to now multiply C with the parity check matrix, which is here.